And what this means is that we expect the users not to be confused. This is a tricky one. So a user needs to understand the different approaches, and so they should not be confused when the response from one tool the response from a tool using one approach is different from the response from a tool using the other approach. So that's what we decided to try and do for Helipal 2. Okay, so how did we do it? What did we decide to do? So the first one, which we've seen in previous webinars, was effectively, if you like, OSLC inviting STEP to play. So you're in OSLC and you have a stream and you want to link to a resource in the STEP world. What you need to do is know what the objective activities are for that resource. If you provide that and time of now, the STEP environment will be able to give you a filter of the structure or the view of the data you're looking at for that time. And similarly for a baseline, provide the objective activity, any conditions, but you also provide it a specific time, which is the time of the freeze of the baseline, and you will get the structure view of that at that particular time. So that's how OSLC invites STEP to play. Doing the other way around, this is what we came up with, was if you're in a STEP configuration management type environment and you're inviting OSLC to play, in order to link to a resource in an OSLC environment, what we decided to do was create a STEP PLM resource with objective activity that represents the resource we're looking at on the OSLC side. So this is I'm going to use this icon in several different places, so you'll see it coming along. So the first thing you do is decide what is the configuration. So you select the configuration from the OSLC side, which is this bit here, and then you select the resource and store the link to that resource. So those two bits together then appear in the in your STEP environment. So what happens is, if the configuration happens to be a baseline, you will always get a fixed version in your STEP environment. If it's a stream, you will get the latest version from the OSLC environment. So that's how we get the OSLC resources to appear in the STEP environment. Okay. So what I'm going to do briefly is an introduction to the demonstration, is a brief reminder of what we saw on the previous webinars, which will give you a context for this webinar. So the first webinar provided by Eric, he was focusing on the architecture and he was explaining why we're doing it. And he was showing a video of OSLC inviting STEP to play. So we saw IBM doors, and it linked to a Links Designer adapter, which pointed at share space. But it was all about the architecture and why we are doing it, the Genesis model. The second webinar given by Jad was a focus on Links Designer and actually how we create these adapters as part of the Helipal project. So these are from Link's work. And he showed an adapter to turn Jira into an OSLC provider, and then they did a demonstration of Polarian talking to that adapter to put OSLC links to Jira. So basically what he was showing was how OSLC can invite anyone to play. It's not just STEP, they can invite anybody to play. So what I'm going to show today is the other way around. So STEP inviting OSLC to play and how we've done it. So I'm focusing on a STEP-based OSLC consumer. So I'm going to be using ShareSpace, and I'm going to show you ShareSpace using OSLC resources, but in a normal STEP way, not in necessarily in an OSLC way. So I'm going to do all the sort of STEP effectivity, configuration management, using OSLC resources. And I'm going to show you, I'm going to reuse the Jira adapter that Jad developed. I'm going to use the ShareSpace links designer adapter that we developed with Jad's help. And if I get time, I've got a screenshot of the Doors Next as well. So we'll show you some of those. Okay. The other thing I'm going to show, which I forgot, is I'm actually creating a new OSLC domain for a STEP part. So the OSLC domains have defects in them, which I'm showing you, which is what the Jira is pointing to, OSLC's defects. But I have created a new domain using the links designer tool, just to show it works. And I'm using that to link ShareSpace to a different installation of ShareSpace. And I can actually do it from Doors as well, which is quite cool. Okay, so this is a demonstration that myself and my colleague Simon did last November. You're welcome to go and see that demonstration. It has a lot of useful information. I'm just going to rattle through it very quickly, but it gives you an idea of configuration management in the STEP type of activity-based thing. Just to set the scene, if you imagine that we have initial design, we're in the frigate design business, and we've designed some frigates for working in a temperate climate. And they're currently in a hot climate. What happens, or what has happened in this completely fictitious scenario, is that there's a pump in this frigate that is now experiencing higher utilization, more extreme usage, which leads to vibration profiles outside the design specification for that pump. And this has some problems, increased risk of failure, and the easy solution is it requires a maintenance interval reduction. So you have to maintain it more often. Okay, so just to show you some of the objects that we're talking about, what I've got here is, it's quite hard to follow what you're looking at in the data if you are not familiar with either ShareSpace or the data. So what I've got is a illustration on the left, and there's what you're looking at in ShareSpace on the right. So we've got a whole bunch of frigates, and you can see them all here. This is all completely made up data. So this is nothing confidential in here. So we've got a whole bunch of ships, and then we have a design breakdown of the class of those ships. So it's frigate design breakdown. So you can see here, it's a breakdown of the frigate class of ships. It's a release breakdown, and the type of breakdown is a hybrid. And the bit we're going to concentrate on is right down in here. We're looking at the foam mist system, which happens to have this pump in it. So that's this bit over here. So these blue things. So I've put some icons down here. These little pink ones are system elements, and we've got some hardware elements in this breakdown. So you can see it's a mixed or a hybrid breakdown. Okay, we've also got a completely independent part structure in the system. So I've got a pump assembly, which has got lots of components in it. Again, I'm just concentrating in here on some of the motor control housing. So we've got some parts in here. We've got some software parts as well in this part structure. And then there's relationships between them. So here we're starting to get into some of those effectivities I'm talking about. So there is a relationship, a realization relationship between the pump in the breakdown structure and the pump part in the part structure. And you can see there is an effectivity on this. So this was a realization from this date. And you can put all sorts of other relationships onto this, other information onto this relationship. But that's the important one from this point of view, or from this webinar. There is an effectivity start date, and because there's no end date, you know it's still effective. Okay, now we get on to some OSLC things. I'm going to get into more detail on how we did it shortly, but this is the first bit of OSLC. I've basically got a pump here. I've created one of these little objects in Jira that has the link to the configuration and the link to the object in Jira. And what it does is I've selected I put a Jira one and a Jira one. But when you click on this object, it shows you the preview. So this is a preview generated by the Links Designer adapter here on top of Jira. So here's the actual Jira record. When you click on this object, it shows you the preview, and then you can click on here and actually go to Jira and see the object. So I've got this object that I've used in our environment in a normal step way that links to the part. Okay, back to our scenario. So imagine we've come up with a solution for the more modern ships that we can add a pump controller on it. There's some reason why they can't be added to the older ones, but they can add to the new ones. We're going to add a new pump controller. Okay, so the first thing we do is create some more definitions of this pump controller in my design breakdown. So I've now got 2 breakdowns from this foam mist system, the original one and a new one, which has got system elements, it's got software elements, it's got hardware elements and control software in here. So the first thing to note is that this pump is actually in both of these different breakdown structures on here. The other thing we do is add to the pump assembly. So again, like I showed before, I've added some strain gauges, but there is a date. So you can see when you added those strain gauges to the pump. Obviously, this is a very simple space allocation, but you can see the idea. I then added a completely new part, which is the control system. So here's my controller. I put it at the top here so to focus on it. It's got some documents. These could be user manuals, installation instructions, data sheets, all sorts of documents you can add in here. And then finally, I've actually added the embedded software, but instead of inserting it in here, I've made it a link. So this is a link to another Jira that houses the software part for that embedded software. And again, when you click on the link, which you can see I have, click on the object, you can see here, it shows you the preview from the other system. You can click on it, the link here, and it'll take you straight there. But the interesting thing here is I'm actually looking at a child relationship between this part and the software. And again, here's my effectivity. So you can see that in early February, I added this child relationship to the assembly. Okay. So how do we do it? I'm just going to jump out from the demo, explain how we did it. So going back to this picture here, first thing we did was use Links Designer to make step parts, and then we updated the adapter, and then we used it. So you go and select that configuration, which is this piece at the top, That then filtered the selection. You selected the resource, which creates this little object inside ShareSpace, and then I can just use it as any other STEP object. You can preview the content, and it can be used by other consumers. So, okay, a bit more detail on each of those. So this is a picture of the Links Designer workspace with the STEP part. It's very simplistic version of STEP part, but anyone familiar with STEP will know about Next Assembly View usages. So we put that in as the definition of the property. Otherwise, it's got the normal sort of things you get in a STEP object. Sorry, in an OSLC object. When we'd done that, we then updated the Links Designer adapter for ShareSpace so that we could then call that and go and make our links to the parts. So that's how we defined it. How we use it then. First thing that happens is you select a configuration. So this is asking the other ShareSpace, what configuration shall I select, which creates this bit here. Once you've selected that, it filters the list based on the object effectivity. Once you've selected one, the other bit it does is it will stop creating duplicates. So it will only allow you to create one of these objects for a known resource. If you try and create another one, it will say to you, I already know about that one, and you use that instead. So now we've got a part here. This is my list of parts, and one of them, or two or three actually, are those resources that are in a different tool. So they're in the other ShareSpace. Okay. Now I've got it, I can just use it as any normal object in the STEP way. So here I am creating the assembly. So there's a normal child, and then I can create, just select this OSLC object as a child, and you can see it's got the effectivity on there. Other things you can do, all sorts of other tools, because it's a normal object. You can do things like where used. So you could see all the objects that are, where is this used? And I've just selected parts, so you could see where it is in any assembly if you've used it in multiple places or you've got multiple links to this object. And then basically every time you click on this object, it'll then show you the preview. So you can see the OSLC preview, which it gets from the Links Designer adapter, and it's displayed in the user interface. And finally, you can use this anywhere. So I just briefly swapped the ShareSpace link to a doors. So I've created a references link from Doors Next Gen, from a requirement in Doors Next Gen to this part. So you can see exactly the same information linked now from Doors. Okay, back to the demo. So we saw this before. There was a realization relationship between the pump and the pump assembly. Similarly, you can create more realization relationships from this new configuration, this new breakdown. Interesting things here. It doesn't have to be a one-to-one. So my sensor in my breakdown structure has got two realizations. So I decided to realize this sensors node with a strain gauge and a vibration sensor. You could have had a combined sensor and it would do one link, or you could have multiple. So the relationships between the structures, which you can put the effectivities on, are multiple. Continuing, the control box. So again, the interesting thing here is that the control box is a sibling of the sensor. and it's pointing to a completely different part. So as I said before, the structures are completely independent, and you put links between them. And then finally, I've linked the control software software element to the resource, which I've now got in ShareSpace. Nearly through. Now, because all these relationships got time on them, at any time you can see what the structure is, and you can also compare over time. So this is a view of our comparison window, and you can see that between these two times, we added these strain gauges. And the final bit I wanted to show was the object effectivity. So because we've now added this new structure, we've decided that the original structure is only applicable to the first chips, and the new structure is only applicable to the new chips. So what you're looking at here is the view with no object effectivity applied. And then I just have a very short video that shows filtering it. So the first thing you do is pick the old ships, and when you filter the structure, you see just the one side of that list. And then if I pick the new one, you see the other side. So this sort of shows the object and dated effectivity working. And the very interesting bit for us, I think we've got this. Oops, sorry, let's go on to the next slide. Is we can use so the STEP implicit configuration management with object effectivity and data effectivity is what I've been showing you, and you can include federated OSLC resources in that STEP configuration, and that's very interesting for us. The other thing you can do, which I showed, was adding STEP constructs. So we very quickly, using the LinksWorks tools, created a new OSLC domain for parts and used it in the in our environment. So we're not restricted to the OSLC domains. You can add more. So just a quick one slide. Conclusions. As I said at the beginning, no one size fits all with configuration management methodology, and therefore all approaches will need to play nicely. But what we've shown is that federation allows that interaction while each side can play by their own rules. So if you allow that federation, and OSLC it is a technology that will allow you to do that. So we've shown that working, and that's really key. So you know, if you're in a later phase of your life cycle of your part, you can use your configuration management suited to that, and then you can still play nicely with your configuration management suited for your requirements domain or your ALM domain. So with that, we've got to the questions. Before we get there, I just wanted to talk about the next webinar, which is on Monday, the 8th of April, the business case for Federated PLM. Josh is going to talk through that, and there's a link there. You can go on LinkedIn and find it from the Federated PLM interest group. So there we go. Very quick rattle through. If there's any questions.
So we haven't received anyone in the chat. So if you have something now, I think you can unmute yourself and ask questions.
And one more thing, we can see how many questions we've got once you unmute, and we can stop the recording if someone wants to ask a question off the record.
So now we have a question from Eric. Can you tell us a bit on the effort required for the implementation?
Yes. The first implementation we did, Jad walked me through it, and let me just go up. The right side. So the first implementation of the adapter, we did something in an afternoon with Jad holding my hand. Now I can add more very quickly. So that part that we added, the step part, I basically did that in 2 days. It was the first time I'd ever done it as well. So learning how to use the links designer modeling environment, updating the adapter, and then updating the client on our side. So Andre did a very good job designing the ShareSpace client such that we can very easily extend it to other types of objects. So there's quite a lot of development work to start with, but we now got to a state where adding new types of objects is very quick and easy.
Judith, I have a question.
Okay.
So when you made, I don't know what you call it, when you got STEP to play OSLC nicely, the last part, how much of the OSLC configuration management do you need?
So yeah, so let's see if I can get to the slide. So slide this one. Nope. Here. So what we need in the STEP environment is to know what the configuration was that from the OSLC environment, and then use it so that when we get the resource we expect. So we don't actually have to use the OSLC configuration management inside of STEP, because we're trying to use the effectivity-based configuration management. But what we do is we effectively use the object effectivity to mimic the mimic the OSLC configuration management for this resource. So if you like, the resource itself is behaving in an OSLC configuration managed way, but then we are using it inside the STEP environment in a STEP way.
But you do need those blue circles, which I assume are OSLC configuration resources.
Yeah, so
local configuration.
Yes.
So you need to implement OSLC like local configuration resources.
Well, not really.
Okay.
As long as we've recorded what the configuration, the OSLC configuration was, and we've know what it is within that box, we don't actually have to have inside the STEP environment the local global configurations that you normally get in a OSLC based environment, because that's not how effectivity based configurations work. So we can play, we can have this object from another environment which we are bringing into ours. The other way around, again, we don't actually have to provide that. Don't have to use that configuration, which is a few slides up. This one, as long as we provide the OSLC environment with what it needs. And this was the right back to the original question. We decided to try and retain the full potential. And in order to do that, this is how we decided to do it. You could get the STEP approach to completely mimic the OSLC approach, but we were trying to retain the STEP-based effectivity type of configurations inside the STEP environment, but then talk to OSLC as OSLC expects us to talk.